Hello Pre-Calc BC. Today we are going to start identifying conics and also talk about the rotation of conics. So the first thing we're going to do is write the general form of a conic. We've been dealing with ellipses and parabolas and hyperbolas, but now this is just going to be a general form for all conics. It is ax squared plus bxy, and this is something new. We'll get to that in a little bit. Plus cy squared plus dx plus ey plus f equals 0. All right, so the conics we have worked with so far have not been rotated, and what that means is that this term right here, this bxy term, is gone, and that b is equal to 0. So when that is the case, it's actually pretty easy to identify when there is a parabola, ellipse, hyperbola, or a circle. So if we have a parabola, that means that we have only one x squared or y squared term, which essentially means that a or c is equal to 0. Okay, so one of these guys is 0, which means that either the x squared or y squared has canceled. When we have a hyperbola, we do have both x squared and y squared, but they have different signs. Okay, x squared and y squared have different signs. This also means that a times c is going to be less than 0. It's going to be a negative. I don't do anything with that. I just look at x squared and y squared and say, oh, they're different signs, so it's a hyperbola. An ellipse, we know we also have x squared and y squared, but this time they will be the same sign. And because of that, again, if you were to multiply a and c, and why you would do that I don't know, but you would get a positive number, and so it would be greater than 0. And finally, for a circle, we know that the radii in the radius in the x direction and in the y direction are the same. And what that ultimately ends up meaning is that a and c have to be equal. Your x squared and your y squared term do have to be the same. All right, so now what we're going to do is we are going to practice identifying each conic. So what I would like you to do is take a minute, pause the video, and look at number 1 through 6. See if using our little definitions from above, if you can determine which conic you are dealing with for 1 through 6. And again, you should be able to do this without completing the square, without graphing, without doing anything, just by looking at the equation. Okay, so again, go ahead, pause the video, give it a try yourself, and then come on back and see if you're right. All right, welcome back. So here are your answers. Let's just run through why these are correct real quickly. So number 1 is an ellipse, and that's because you have x squared and y squared, but they are both the same sign. They're both positives. Number 2 is a circle because you just have a 1x squared and a 1y squared. Those are the same value. This is also in the general form of a circle, so that one is just done. Hyperbola is number 3, and that's because you do have an x squared and a y squared, but they are different signs. It doesn't matter that they both have a value of 1 in front because they are different signs. So this is not a circle, it is a hyperbola. Number 4 is a parabola because you only have an x squared, you do not have a y squared. Number 5 is a hyperbola because you have an x squared and y squared, but they are different signs. And finally, number 6 is an ellipse because you have an x squared and a y squared, and they are the same sign. All right, so now we're going to talk about this xy term, which was above with letter B. So when conics have an xy term, unfortunately, you cannot just look at the equation to determine what the conic is. Instead, we are going to use b squared minus 4ac, which you should recognize from quadratic formula. Don't worry, we're not going to do quadratic formula right now, but you do need to know b squared minus 4ac. So if you have a parabola, what ends up happening is that b squared minus 4ac equals 0. If you have an ellipse, b squared minus 4ac is less than 0. And if you have a hyperbola, it is greater than 0. Okay, so ellipse less than 0, hyperbola greater than 0. So here's what you would do. Your a term is what's with x squared. Your b is what's with your xy. And your c is what's with your y squared. So notice they might not be in this order. You need to find your x squared, your xy, your y squared. That's what you're looking for. And then you're just going to plug your numbers in. So b squared minus 4ac is negative 3 squared minus 4 times 2 times 4. And that gives you a negative 23. And negative 23 is less than 0. And so we have an ellipse. All right, and that's how you identify a rotated conic. So now, if you flip the page, we are going to talk about the rotation of axes. This is really an introduction to what we're going to be doing tomorrow. This is like the prequel to it. So rotation of axes is when there's no xy term in an equation, we need to transform the equation, or excuse me, when there is an xy term in an equation, we need to transform the equation and rotate our axes so there is no xy term. So here's what you've got. Basically, you've got your normal xy axis. And what we are going to be doing is physically rotating our axes. So for example, this is the x-axis. This is now our x prime axis. And this was our y-axis, and now this is our y prime axis. And we would be graphing on that axis, or axes. Okay? So there are two rotation formulas that you need to memorize. And this is going to be very, very, very abstract right now. I'm just warning you. So for right now, you're just going to memorize these formulas. X equals x prime cosine theta minus y prime sine theta. And one more, y equals x prime sine theta plus y prime cosine theta. Okay, and what we're going to use to find theta is this little formula right here. Cotangent of 2 theta is equal to a minus c over b. And the a, b, and c are the values that we would have just used in the last problem. Okay, so you would find your x squared, your xy, and your y squared terms. A couple comments. If your cotangent of 2 theta is greater than or equal to 0, so cotangent is positive, that means that 0 is between, or excuse me, 2 theta is between 0 and 90 degrees, basically quadrant 1. So that means your theta is between 0 and 45. And if your cotangent of 2 theta is less than or equal to 0, meaning negative, then you're going to be between 90 and 180 degrees. So over here for 2 theta, or between 45 and 90 for your theta. All right, so that is just something to keep in mind. I'll show you more how to work with that in a moment. All right, so let's try this 2 times. We're going to find the correct rotation formulas to eliminate the xy term. We're not actually going to eliminate the xy term today. I'm going to show you how to do that tomorrow. But what we are doing here is necessary for what we're going to do tomorrow. All right, so here's the first thing you're going to do. You're going to identify your A, which is 1, your B, which is negative 4, and your C, which is also a 1. And just for practice here, let's go ahead and figure out what type of problem this is, or what type of a conic. So to do that, I'll do b squared minus 4ac, negative 4 squared, minus 4, 1, 1. And that's going to be 16 minus 4, which is 12. 12 is greater than 0. So this is going to be a hyperbola. Again, you're not going to actually see the hyperbola right now. We're going to talk about that tomorrow. But this is a hyperbola that has been rotated. So the next thing I'm going to do is I'm going to find my angle, and I'm going to use that formula from above. Cotangent of 2 theta equals, and again, it's A minus C over B. All right, so we're going to plug our A, B, and C in. We just used those above. A was 1, C was 1, B was -4. 1 minus 1 is 0 over -4. 0 divided by -4 is 0. All right, I'm going to come up here real quick. So I have cotangent of 2 theta equals 0. So we need to figure out where that is. So let's think about our unit circle real quickly. So when we're dealing with a cotangent of 0, you need to figure out, oops, I switched those, whether you are over here at 1, 0 or up here at 0, 1. Cotangent, if you recall, is cosine over sine, or just the reciprocal of tangent. Cosine over sine means we're doing our x value divided by our y value. So take a look, which of these 2 points would give you a cotangent of 0? And that would be right up here at 90 degrees, because 0 divided by 1 is 0, as opposed to 1 divided by 0 is undefined, down here at 0 degrees. So this means that 2 theta is 90 degrees. Okay? And if 2 theta is 90 degrees, then theta must be 45 degrees. And this is everybody's favorite because everyone loves a 45-degree angle. Okay? So now what we're going to do is we're going to come over and we're going to use those other 2 formulas from above. We have x equals x prime cosine theta minus y prime sine theta. And then the only thing you need to plug in is the 45 degrees. X prime cosine 45 minus y prime sine 45. And now these we are going to evaluate. Cosine of 45 is just root 2 over 2. So this is root 2 over 2 x prime minus sine of 45 is also root 2 over 2. So root 2 over 2 y prime. And then since these are the same, what we do a lot of times is we pull that root 2 over 2 out. And we just write it like this. All right, so that is our first rotation formula, and now we're going to write the second one. So the second one was y equals x prime sine theta plus y prime cosine theta. And again, you are just plugging in 45 for your thetas. That's the only thing you're plugging in. And again, you're going to go, oh, well, sine of 45 is just root 2 over 2. And cosine of 45 is also root 2 over 2. And once more, you will find it helpful tomorrow to factor out that root 2 over 2, and you're just going to have x prime plus y prime. All right, and there are your rotation formulas. And I know right now you're like, why do I have this? But you're just going to have to wait until tomorrow, and you'll see why we use it. All right, so now we're going to try one more of these. Okay, so first step, identify ABC. A, B, C, it's just going to be 1. And let's figure out whether this is a hyperbola, ellipse, or parabola. And we do that with b squared minus 4ac. So 10 root 3 squared minus 4, 11, 1. All right, let's see here. This would be 100 times 3, which is 300, minus 44, which is 256. And that is a positive value. Sorry, it's been a long winter break. Yes, 256. Good job for me. 256 is a positive value greater than 0. And so what that means is we are dealing with a hyperbola as well. All right, so now we are going to find our angle of rotation. And you can rotate at any angle. However, we're going to focus primarily on 30 degrees, 45 degrees, and 60 degrees because it's going to get messy enough not using those angles. But you could rotate at any angle. All right, anyways, back to our formula. Cotangent of 2 theta equals A minus C over B. And our A value is 11, minus C is 1, over B is 10 root 3, which is 10 over 10 root 3, which is 1 over root 3. Okay, so I know you have missed your unit circle. So, again, we're dealing with tangent. The 3 main tangents we have in our unit circle are a tangent of 1, a tangent of root 3, and a tangent of 1 over root 3. And you need to know which angle is which. So, let's do our unit circle real quick. This is supposed to be a 30-degree angle. At 30 degrees, or pi over 6, you should know that we have a root 3 over 2, comma 1/2. At 45 degrees, we just did that, root 2 over 2, root 2 over 2. And at 60 degrees, 1/2, root 3 over 2. Okay, again, we are dealing with cotangent, not tangent. So we are doing cosine over sine, or x over y. Okay, so x over y means that it's going to be the 60 degrees that gives us a cotangent of 1 over root 3. So 2 theta equals 60 degrees. Divide by 2 on both sides. Our angle of rotation is 30 degrees. All right, so now we're going to do our 2 rotation formulas, which I guess I have room for over here. So we have x equals x prime cosine theta minus y prime sine theta. And we have y equals x prime sine theta plus y prime cosine theta. And you again are just plugging in the 30 degrees. And then we're going to evaluate. I'll just finish this one. Okay, so the cosine of 30 is cosine of 30 is root 3 over 2. All right, root 3 over 2. And the sine of 30 is 1/2. And if you want to factor out a 1/2, you can, but honestly, it doesn't really help you. I only do it for 45 degrees because you have the root 2 over 2 that is in front of both your x prime and y prime. So this is just done. And then this one's going to look very similar. Again, you're just plugging in your 30. And again, cosine of 30 is root 3. Oops, sorry. Look at that. That's a sine. Sine of 30 is 1/2. And cosine of 30 is root 3 over 2. So be careful to not switch your sines and cosines. All right, and there you go. Those are your rotation formulas. Stay tuned to tomorrow's lesson where we actually rotate our conics. It's going to be thrilling. You're just going to love it. Bye-bye.